Hi everyone. In this video we are going to learn how to find the change in the electric force between two charges if the distance, for example, between the charges change or the value of the charges change. So let's say we have two charges, Q1 and Q2, and let's say the distance between them is R. And the force, since they have same sign, the force will be repulsive. Let's say the force between them is F. So the question will be, what happens to the force? What happens to the force if the distance is doubled, for example? If the distance is doubled. All right, so how do we do such problem? The easy way is to do it like that. The new force, or the formula of the force, is simply K Q1 Q2 over R squared. Now, since the distance is double, this means this R is simply multiplied by 2. So this one becomes, I keep what I wrote in blue, we keep it in blue, K Q1 Q2 divided by R squared, and 2 power 2 becomes 4. So this means I should divide the left-hand side by 4 to keep the equality between the right and left-hand side. So the conclusion is that the force decreased by a factor of 4. The force decreased by a factor of 4. All right, another example. Let's say we have those two charges, for instance, and I have Q, both of them are Q and Q, which is minus Q in that case, and the distance is R. And let's say also the force between them is F, but now it's an attractive force. So the question is, what happens to the force? What happens to the force? Let's call them Q1 and Q2, right? Q1 and Q2. What happens to the force if both charges are doubled and the distance is doubled as well? Again, this F will be K Q1 Q2 divided by R squared. Now both charges are doubled, so I have to multiply 2 for Q1 and 2 for Q2. And the distance is doubled, so this one becomes 2R squared. So the equation becomes K, I have Q1 and the Q2, and in red I have 2 times 2, which is 4. And in the denominator I have 2 squared, which is 4, and here I have R squared. So 4 and 4 cancels. This means nothing happens to the force. The force remains the same. So the answer, the force remains the same. Last example. What happens if the distance is halved to the force? If the distance is halved. Again, we write the formula. F is K Q1 Q2 over R squared. Now the distance is halved. This one becomes over 2. So it becomes now K Q1 Q2 over R squared. 2 squared becomes 4. So this one is divided by 4. Since it is in the denominator of the denominator, this one goes up. This one goes up. Okay, so it becomes, F becomes K Q1 Q2 over R squared, and I have 4 here up in the numerator. So this means I have to multiply this F by 4. So this means the force increased 4 times or quadruple. So the force increases 4 times, or we say quadrupled. Thank you for watching.